All right, guys, welcome back. We're going to start lesson 4.6, completing the square, and then quadratic formula, lesson 4.7, that's going to be a separate lesson. So right now we're just going to focus on completing the square. Okay, now what's the purpose of completing the square? We've looked at quadratics in standard form. Okay, that's how we've seen them since Algebra 1. All right, ax squared plus bx plus c. And then we just learned at the beginning of this year the vertex form, okay, using a, h, and k. That way we can quickly identify the location. Couple different reasons we need to convert from standard form to vertex form. One, to find the location, and two, just so we have a solving method. If something is not factorable, if we put it in vertex form, we could at least solve by undoing using square roots, okay? So you'll see what I mean here once we get going. So some of the quadratics, like I said before, can be easily factored and solved for using zero product property. Others cannot be factored, okay? Probably because our answers are going to be irrational. They're going to be irrational exponents, all right? So we're going to use the method called completing the square. So we're going to do it two ways. One way, when the a value is 1, it's a lot easier. The second way is when the a value is not 1. You can still use the method of completing the square. We're going to do a couple examples, but that's where the quadratic formula might be introduced because that might be a little cleaner to use. Okay, so once we lay out all of our procedures on the table, our different methods, then you get to choose which method you feel is the most convenient for that situation. So just a quick rundown here. Here's step by step what you would do and how you would complete the square. The constant must be on the right side of the equal sign, so you're going to move your c value over. Okay, you're going to add or subtract that over. All right. Step 2 and 3 are kind of simultaneous. You're going to take half of your b coefficient, okay, and then step 3 you're going to square it. All right. So with that answer, b divided by 2 squared, all right, you are going to add that to both sides of your equation. All right. So say your bx term is 6, so b is 6 divided by 2 is 3. 3 squared is 9. You're going to add 9 to the left side of the equation. So in order to keep it balanced and maintain equality, you have to add 9 to the right side of the equation. All right. So if we're adding the same number to both sides, we maintain equality, so we didn't change the value of the equation. All right. Step 5, we're going to factor the left side into a perfect square. And then step 6, we're going to solve it by taking square roots, okay, and continuing to undo the equation. All right. So let's get into it here. First one. So step 1, we're going to move our c term over. So we're going to add 9 to both sides. Now, I left a little hole there, a little gap here. That's where I'm going to add my b divided by 2 squared. Okay, I should actually backtrack. The original equation there, if you notice, if you try to factor it, what multiplies to be negative 9 and adds to be 16, it's not possible. It's not factorable. So we have to come up with another way to solve, all right, which is why we're doing what we're doing. All right. So step 2 and 3, take your b term, which is 16, divided by 2 is 8. 8 squared is 64. So I'm going to add 64 here and subtract 64 here. All right. Now, this method is called completing the square for that exact reason. What we just made here is a perfect square. All right. So the quickest way to do that, because we forced it to happen, is you take x and then you just take your b value and divide it by 2. All right, so x plus 8 quantity squared will be your perfect square. Okay, I have a mistake already. Got to add 64 to both sides. All right, so now as I continue, all right, I get 9 and 64, which is 73. So real quick, what I want to do is just to make sure I'm dealing with the correct equation, I didn't accidentally mess up. I'm going to go to Desmos and I'm going to type this equation in and I'm going to type this equation in, except I'm going to move my 73 over and I just want to make sure they're the same equation. So here's my two equations, all right, and you can see that when I click one, the other one just goes right over top of it. Okay, so I know that those two equations are in fact equivalent, all right, which is good news for us. So to continue solving, all right, all we do is, to get into the x, we have to take the square root of both sides. So we square root both sides. I have x plus 8 equals plus or minus the square root of 73. 73 is actually prime, therefore I cannot simplify that radical any further. And my final answer is negative 8 plus or minus the square root of 73. Now, on your calculators, you could definitely evaluate this. Negative 8 plus the square root of 73, get your answer. Negative 8 minus the square root of 73, get your answer. And then we could always go back to our Desmos and click on those x-intercepts to confirm these two. So 0.544 and negative 16.544. Let's check it out. Okay, there's your negative 16.544 and there's your 0.544. Okay, so that one is correct. Had we tried to factor it, we would have hit a brick wall, we would hit a dead end, we would not have a solving method, all right? So completing the square is definitely a valuable tool in solving for x-intercepts, okay? All right, let's try another example. X squared minus 6x plus 25, once again, cannot be factored. Therefore, I go to my steps for completing the square. All right, move your C term over. All right, so we subtract 25 over. Now we do our b divided by 2 and then square it. So b is negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. So I add that to both sides. Okay. This makes a perfect square. So I just do x and then our b value divided by 2. Quantity squared. And negative 25 and 9 is negative 16. Okay, so once again, just to be sure, I'm going to check both of these, except my bottom equation there. I'm going to add the 16 over to the other side. I want to see if they are indeed equivalent. So right there they are. And again, you can see one's green. I highlight equation 2. Okay, it goes right over top of it. Okay, so I check to make sure both forms are equivalent. Let's go back to solving. So if we were to finish solving this out, we take the square root of both sides. Unfortunately, I cannot do that. Okay, can't take the square root of a negative. Therefore, I have no real solutions, which equates to no x-intercepts. All right. If any of you took notice back in Desmos at our graphs, here's the x-axis down below, okay, and I do not cross the x-axis anywhere, which confirms our algebraic work. Okay, let's continue on with the slides. This one here, I want you guys to try, all right? So as in some previous videos, take the opportunity to pause and complete it on your own, and then you can scroll ahead to see my solution, all right? All right, I'm going to add 33 to both sides to get my C term over there. All right, fill this in with my b divided by 2 squared, both sides. 8 divided by 2 is 4. 4 squared is 16. All right, now my perfect square is just x and then b divided by 2, which is positive 4. Okay, so that term is always just b divided by 2. And then the sum of 33 and 16 is 49. All right, continue solving by taking the square root of both sides. I get x plus 4 equals plus or minus 7, perfect square. Subtract 4, x equals negative 4 plus or minus 7. So I can split that. I can do my negative 4 plus 7, which is 3, negative 4 minus 7, which is negative 11. Therefore, these are my two x-intercepts. Okay. One thing I could have done in the middle of that process is go to Desmos and confirm the original equation with the one down here before I started square rooting. Just move your 49 over and then confirm your x-intercepts of 3 and negative 11. So let's check it out. So there they are. There's my first graph. Highlight the second one, goes right over top of it, which is a good sign. All right, and then I can confirm these x-intercepts. There's my negative 11, and there's my positive 3. Okay, so you can check everything that you're doing along the way if you have a graphing calculator or a graphing tool. All right. Now we're going to get into where it becomes a little bit more difficult. Okay, what happens when the a value is not 1? Okay, we have to make it 1, essentially. All right, so step 1 is going to be the same. Okay, we're going to start here and move that c term over, and then we're going to factor out the a value. All right, this could potentially get messy. We're going to do one that's kind of clean and one that's kind of messy. But this is where maybe we come up with an alternative method, which we'll do the next day, which is the quadratic formula. Okay, but it can still be done. All right, for graphing purposes, this might be the way you have to go. All right, so we'll kick around some ideas in the future. Like I said before, once all of our methods are laid out, you'll have the choice and the option to choose whatever method you want according to the situation. Okay? The only kicker for this one is in step 4 is when you add your b divided by 2 squared to both sides, you have to take your a value. We have to preserve that a value. So if we're multiplying by 3 on the left, we're going to multiply that by 3 on the right. Just what we're adding to both sides. Okay, you'll see what I mean here. I'll talk you through it. All right. So the first example, we kind of scripted out for you guys. As you can see, we moved our 4 over first, okay, and then we pulled a 3 out of what's left on the other side. So this would have been 3x squared plus 6x equals 4, and then we pulled the 3 out because the a value has to equal 1. Okay, so once again, my b term is 2. 2 divided by 2 is 1. 1 squared, which is why a 1 goes here. And then a 1 goes here. But remember I said, since this coefficient is 3 on the left, if I were to distribute that back, that would be a 3 in there, which means I added 3 on the left side, not a 1. That's why I have to multiply, keep that same a value, times whatever you're adding on this side. Okay, so you put 1 on both sides, you got to multiply both by 3. Okay, just on the right side there, the left side's already taken care of because your a value is still there, your coefficient's still out front. All right, this right here forms your perfect square, x plus 1 quantity squared, a value comes down, 4 plus 3 is 7, and then we divide by 3 to get 7/3, square root, so we get plus or minus the square root, and then we subtract 1 to obtain this answer. Okay, let's try another one. Okay, that's a lot to digest right now, so I'm with you. Okay, this one gets a little sloppier, so I used my graphing calculator to keep everything as an improper fraction. So if you're wondering where these fractions came from, that's where they came from. So step 1, I'm going to move my c term over, and then I have to pull a 3 out of this. Okay, which makes this pretty sloppy. All right, so because this a value over here is 3, whatever I'm adding, my b divided by 2, I have to multiply by 3 over here. Okay? So if you're doing this on a calculator, have one by, I took 5/3, because that's my b value, divided it by 2, and then squared it, and then converted that into an improper fraction, okay, which is 25/36. So I add that to both sides, okay? So once again, here, it's just x and then b divided by 2. 5/3 divided by 2 is 5/6, quantity squared. And my right side, when I crunch 7 plus 3 times 25/36, I get 109/12. Okay. So if I want to make sure I'm right, because I'm dealing with a lot of messy fractions, I can type in my original, and then I'm going to type in this line here, but I'm going to subtract the 109/12. So let's see here. So there's my first one, okay, the original. Here it is in graphing vertex form, which goes right over top of it, which is a good feeling, okay? So I know it's equivalent. All right, so since I know it's equivalent, I can proceed in solving. All right, so to get to x, I'm going to divide everything by 3. That's 109/36. Take the square root of both sides. I'll come back up here. We'll do x plus 5/6 equals plus or minus the square root of 109, and the square root of 36 is actually 6, so the denominator cleans up nicely. All right, subtract 5/6 on both sides. X equals negative 5/6 plus or minus the square root of 109 divided by 6. And to confirm those x-intercepts, again, you would just evaluate that on your calculator. You can jam that in. When you do the plus side of it, you should get 0.907, and the minus side of it, negative 2.573. All right, so these would be your two x-intercepts from that equation. And we can always get back to the graph to confirm them. Okay, so let me go back. 0.907, negative 2.573. 0.907, negative 2.573. Okay? All right. Last problem here. I want you guys to try it on your own. All right. So feel free to pause the video and do this on your own. This one is a lot cleaner and a lot nicer, so good luck when you do it. I'm going to get started. Move my C term over, make my coefficient 1, which means I need to factor out a 2. You can see that this is nice when it divides evenly. And because my a value on the left is 2, whatever I get, my b divided by 2 squared term to add to both sides, I have to multiply that by 2 as well. All right. So here my b term is 4, so 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 here and put 4 there. The left side, that turns to x plus 2 squared. Again, I got this 2 by just taking b divided by 2. It's a shortcut. The coefficient comes down. Right side turns into 18. Okay. So before you move on, confirm your original line up here, subtract 18 and type that in, Desmos. Okay, I have it here. There's my original. There's my new one, goes right over top of it. Beautiful. All right, I know I'm right. I'm feeling good about it. Go back here and finish solving this. So divide both sides by 2. square root of both sides. So x plus 2 equals plus or minus 3. Subtract 2. X equals negative 2 plus or minus 3. And then we can split that. Negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. And these are your two x-intercepts. Okay, so 1 and negative 5. Go back to our graph, confirm our answer. There's positive 1. There's negative 5. Okay, so the nice part about algebra is you can check your work. Okay, you can substitute into a graph, confirm it graphically, substitute it back in algebraically, confirm it that way. I like seeing it. So the graphical approach is nice to receive confirmation, whether it's from your graphing calculator or Desmos. Okay, you can touch the graph and find those nice points. Okay, the last thing here's another additional video. If you're still struggling, you can watch this and click on the link and see. If this video helps you, feel free to rewatch my video, but definitely when you return to class, if there's any questions or concerns you have, we're going to practice some more just to solidify this technique, because it is definitely very beneficial in the event that a quadratic is not factorable. Okay, you have to have an alternative method to solve. Okay, so we'll try a couple when we get to class, and look forward to seeing you then.